Today, we're getting under the hood of electric vehicles. But, we're not talking about horsepower or 0 to 60 times. We're talking about survival. We're going to break down the 5 absolute must-know principles for safely depowering and working on these high-voltage systems. So, let's dive in. So the very first thing you have to get your head around is the sheer power we're dealing with. Just forget everything you know about that familiar 12-volt battery. We are now in a world of systems that can easily push 650 volts, or even more. It's a completely different and much more dangerous ballgame. And what makes this so incredibly dangerous is that this power is completely silent and invisible. There's no warning rattle, no smell of leaking gas. One wrong move, and the consequence isn't just a busted knuckle, it's immediate and it's severe. This isn't just more power. It demands a whole new level of respect. And that brings us right to our first principle, recognizing that this is a completely different category of risk. This is all about reframing your entire mindset for the high-voltage environment you're about to step into. Look, this isn't about guesswork or relying on old habits. In Australia, for example, every single action is governed by the AS5732 standard. You need to think of this as the non-negotiable legal and procedural framework for all high-voltage work. It's not a guideline. It's the rulebook that's going to save your life. And if you think that sounds like an exaggeration, listen to this. The source material puts it perfectly. These are not standard automotive WHS precautions. They are specific HV electrical safety requirements, a life-threatening error. I mean, that really hammers the point home, right? Your old habits from working on combustion engines aren't just wrong here, they are potentially fatal. All right, let's move on to principle number 2, the rules of engagement. This is all about your personal protective equipment and the strict protocols you have to follow. Honestly, you should think of it as your high-voltage armor. And let me be clear, none of these are optional. They are your first and last line of defense. We're talking 1,000-volt rated gloves, an insulating mat to isolate you from the ground, and always following the one-hand rule to keep the current path away from your heart. It also means absolutely no jewelry, no metal, and locating the correct fire extinguisher before you even think about starting. Every single one is a critical barrier. Okay, so you're all geared up. Now what? Well, principle 3 is you have to know the blueprint. Before you touch a single thing, you have to understand the vehicle's 2 completely separate electrical nervous systems, the RESS and the SELV systems. So on one side, you've got the SELV, or Separated Extra Low Voltage System. That's your familiar 12 or 24 volt setup that runs the lights, the computers, all the safety interlocks. It's pretty low risk. But on the other side, you have the RES, the Rechargeable Energy Storage System. This is the high-voltage beast, pushing 650 volts or more to power the drive motor. The danger here? It is absolutely lethal on contact. And here's why that distinction is literally a matter of life or death. If you disconnect these systems in the wrong order, you can leave high-voltage circuits energized, just waiting for a path to ground, which could be you. It can also send voltage spikes that will instantly fry expensive and critical ECUs. So you see, understanding this architecture isn't just good practice, it's fundamental to the entire depowering sequence. And that leads us directly to the absolute core of this whole thing. Principle number 4, the discipline of depowering. This is not a rough guide, okay? It is a precise, unchangeable sequence to isolate the power and then verify that it's truly 100% gone. This 4-step sequence has to be followed exactly, every single time. First, you disconnect the low-voltage SELV supply. Second, you remove the RES service plug, which physically isolates the high-voltage battery. Third, and this is completely non-negotiable, you wait the manufacturer's specified time, then you test the system to confirm 0 residual voltage. And finally, you physically secure that service plug on your person so that nobody can accidentally re-energize the system while you're working. So why that wait and test step? It's because of something called residual voltage. Even with the battery completely disconnected, the system's capacitors can hold a lethal charge for several minutes. It's like a ghost in the machine that you have to absolutely prove is gone before you can safely move forward. And how do you prove it's gone? With the right tool. This quote is a really stark warning. Using a lower-rated meter on HV circuits can result in meter destruction and electrical explosion. See, this isn't just about getting a correct reading, it's about preventing the tool in your own hands from becoming a dangerous weapon. And this right here is exactly what that warning means in the real world. On the left, you've got the correct tool, a Cat3 1000-volt multimeter, specifically rated for the high energy in these systems. On the right, a standard meter you might use for household circuits. If you use that on an EV, it's not just going to be inaccurate, it can cause the meter to literally explode in your hands, creating an arc flash and causing severe burns. That CAT rating isn't a suggestion, it's a critical safety specification. Okay, we've safely shut it down, but the job's not over. That brings us to our final principle, number 5, the professional's handshake. This is all about reinitialization and final checks, because getting the power back on safely is just as critical as shutting it down. Now, the process is basically the reverse of depowering, but with some really crucial final steps. You reinstall the rest service plug, and then you reconnect the low-voltage SLV supply. Next, and you absolutely cannot skip this, you have to use a scan tool to recalibrate all the subsystems that were affected by the power loss, like the driver assist systems. Then you confirm all the vehicle's functions are operating correctly, and finally, you document every single step you took. And make no mistake, skipping that recalibration step can be disastrous. An unreported fault could cause a critical safety system, like automated braking or lane assist, to fail when your customer's out on the highway. This final discipline protects the driver, it protects the workshop, and it protects your professional integrity. So when you look at the whole process, from having the right mindset to wearing the right armor to that final professional handshake, it all comes down to this. In the high-voltage world, there are no shortcuts. Every connection, every test, and every single step is a deliberate choice. So the only question left is, are you making the safe, precise, and professional one?